Okay, in this question we've got, they give us a function, and the first thing they ask us to determine the derivative of this from first principles. Let's see what student did. Okay, he said, okay, started with our derivative function, formula, from first principles is the derivative formula, and then if x plus h just means we substitute every term, every x with an x plus h. So there's my expression, 2x squared minus 7x plus 3, I think so, yeah, and then every x just gets an x plus h instead. And so then we simplify this, we multiply it out. We know the rule is, or the principle is that in the end, everything that does not have an h should cancel. Okay, if it doesn't, I've made a mistake somewhere. So 2x squared cancel with negative 2x squared, negative 7x with positive 7x, and the plus 3 with the minus 3. So that I'm left, I can take out my constant h. In every term now has to have an h. I take out my common h, common factor in each one, cancel it, and I'm left with this expression. Now I'm allowed to substitute my h with 0, and this student did it absolutely perfect. You couldn't do it better, because the moment you substitute h with 0, you have to lose the limit. If you lose the limit anytime sooner, you lose a mark, because the limit shows that we're still looking for the limit as h tends to 0. We can't substitute it because it gives us a 0 in the denominator. So very good, students, excellent. Okay, the next question, determine the equation of the tangent at the point where x is equal to 1 on the curve. Okay, so now we have the derivative, and we should work out the tangent line to that curve. So here we have the derivative. I don't know why he makes it equal to 0. When you make the derivative equal to 0, you're trying to find the turning point. If we want to find the tangent line, and they tell us where the tangent line is, so any line, if we want any line, we need the y is equal to, okay, let's get this started, 2mx plus c. And so if we want any line, whether it's tangent line, any line, one of the first things, or probably the thing we actually want, is the gradient. And the gradient of a tangent line is just equal to the derivative of the function that it's tangent to at the point where I want the tangent line to be. So in this case, they said when x is equal to -1. I think so. When x is equal to -1. And so, yeah, if I go back there, that's it. I just take the derivative, which was 2x minus 7, and I substitute my -1. So the derivative in -1 is 2 -1 7 is equal to -9, so that y is equal to -9x plus c. Now I need another point on the graph, because I've got one parameter left to solve, so I need another point on the graph. I'm not given any other points, but what I am given is x is equal to -1. I need the y value associated with this x value. Now this, I don't have a y value given, but I have a formula for y values. G of x is a formula for all the y values. I can substitute any x and get a y value. And so that's then the next step. So g of -1 will give me my y value. Y is equal to this. G of -1 will give me -1, 2 times -1 squared minus 7 times -1 plus 3, I think. Is it? Plus 3, yeah. And so this is 2 plus 7 plus 3 is 12. Okay, so I get 12 is equal to -9, -1 plus c. So c is equal to the 9 becomes positive 9, and so 9 plus 3 is equal to 12. And so here's my final answer, negative 9x plus 3. Okay, so remember that when I want to get a tangent line to a curve, I don't make the derivative equal to 0. I make the derivative equal to 0 if that gives me where is the gradient of my curve, my graph, equal to 0. That's usually at a turning point. Okay, and so we do that when we want a minimum or a maximum value, because minimums and maximums occur at turning points. Okay, so then the next one, next question, is to find the derivative of this expression. There I go, find the derivative. First, I'll need to simplify. I cannot find the derivative in this form. I need the form with a base and exponent, or I need terms. In a sense, polynomial expressions, but polynomials don't have fraction exponents, but the idea is there. I want a polynomial type expression. So I first have to simplify. I do that by distributing the denominator to each term, then dividing. This means I subtract exponents. So this is 1 minus a half, which is a half. This one is x to the power of 0 minus a half is negative a half. And this is, again, perfectly done. We've not been finding the derivative, so the expression stays y. It's y is equal to y is equal to. Then the moment we find the derivative, this is a half x to the power of negative a half minus, we just multiply the coefficient in front, the exponent with the coefficient, and then subtract 1. And this is exactly what we get. Sometimes they might ask you to leave your answer with positive exponents or with no fractional exponents, and in that case we'll have to go back and make this a half as 1 over 2 square root x, and this one negative 7 over 2 square root x to the power of 3. Okay, I'm not going to do that because that wasn't asked. If you do want, just always look if they so read your instructions. It could just be in the instructions. So just because it's not said there doesn't mean it wasn't said in the instructions. So it's not said in these instructions. Okay, next question. Here's find the derivative of this thing. Oh, that's so super easy. Okay, so to find the derivative of that, we just had x to the power of negative 4 is multiplied in front. Okay, this one is wrong though. I mean, that's not true. This is not true. Okay, so this is just x divided by 2. This means it's the square root of x. Okay, this is just equal to a half x. Okay, so that's a common mistake. So but the rest is perfectly fine. Just multiply the exponent to the front, subtract 1, etc., etc. Okay, good, we can move on. Okay, question 9, and please note that you will get questions like this. This is very common. There'll definitely be something like this, definitely something like this, definitely a polynomial and some sort of questions regarding that. Prove that x minus 2 is a factor of fx. So if something is a factor, an expression is a factor, I make that expression equal to 0, solve x, and if I substitute that answer into here and I get 0, then it's a factor. And I think that's exactly what the student did. Okay, there it is. If we make this equal to 0, x minus 2, then x is equal to 2. And so substituting 2 in here, I get it's 0. So therefore, we've proved that x minus 2 is a factor. Very good, good work done. Okay, second part of the question is to determine the x-intercept and the y-intercept of f of x. So if we look at that, x-intercept, for the y-intercept, we make x 0. So excellent. X is 0. We just left with 0, 16. Okay, for the y-intercept, we make, for the x-intercept, we make y 0. And then we have to simplify, we have to factorize this expression. And so I see he couldn't do it again. And And so let me just show you how simple it is. X cubed minus 12x plus 16. Okay. X cubed minus 12x plus 16. We already know that x minus 2 is a factor. Okay, so we want to know what is the remainder, not the remainder, what's the quotient when I divide, the remainder is 0. The quotient when I divide this. Okay, so we notice that in order to get that, we're going to need an x square, an x term, and a constant number here at the back. So to get the x squared term, it's x times x squared. Sorry, to get the coefficient, this one times this one, the first one and the last one must give me this first one, which is just a 1. So this must just be a 1. Okay, to get the last term is also easy, because the first number, the last number here and the last number here must give me the last number there, which is 16. Positive 16, so this must be a negative 8. So negative 8 and negative 2 is positive 16. The problem is this term here. Let's call it again k. Now notice that the k is more difficult to find, because in order to find the k, I need to get, for example, in the top, there's a plus 0x squared. But x squared is not just found by multiplying two terms together, but two terms are multiplied with each other plus another two terms. So for example, look here, I'll do it in a different color. Okay, when I multiply 2 with x with this, I get 2x squared. I also get an x squared when I multiply x with kx. So that is plus kx squared. And that should give me the 0x squared. So it's fairly easy now. I know, oh, that must then be negative 2x squared, because 2x squared minus 2x squared will give me 0x squared. So it is fairly easy. But let me just then do the long method to show you, come on guys, this is not so difficult. X cubed. Now, when there's an x squared term missing, I just put in 0x squared. Plus, now there's a actually a minus 12x plus 16. And now I just divide. So x divides into there, x squared. I'm going to do it fast so that I can move on. So now I subtract and I get 2x squared. Bring down the negative 12x. Then again divide the 2 in the x in there, so I get positive. Why isn't this negative? Oh, because this should have been negative. Sorry, I made a mistake. This one and that one gives me negative 2x, so this one is positive 2x. Okay, so there, that mistake slipped in, so that I've got x minus 2 x squared plus 2x plus minus 8. And this factorizes, I'll finish this other side just now, sorry. X, that one factorizes into x plus 4x minus 2. Okay, and so let me just show you, I get the same thing here. X divides into there plus 2x times, and then when I multiply it back, I get 2x squared minus 4x, and then if I subtract it, change the signs, I get 0 minus 8x, bring down the 16 plus 16, divide it for a last time, I get negative 8, multiply it back, I get negative 8x, positive 16, and then when my signs change, I get 0, which is what I must get, because this is my remainder and x minus 2 is a factor, so my remainder must be 0. Okay, and that is how you get these two factors. Now I was supposed to get the x-intercept, so I get x is equal to 2 or x is equal to -4. That's the x-intercept. Let's see, next question. Draw the graph of f in your answer book. Show all the intercepts with the axis. And okay, this student didn't do anything. Guys, even if you couldn't, and the point of inflection, if you couldn't draw it, okay, or if you couldn't find the intercepts, just draw the shape at least. Okay, so, but I'll draw it in here. Okay, let's draw it here. So first of all, it's got a positive shape, and so I would have gotten one point just for drawing the correct shape, which is an n shape. When a, that is the coefficient of the x squared, if that is positive, then I've got that shape. Okay, now the next thing is that when I did this, I could see that there's at x2, and there's double roots, or we call it roots with multiplicity. So that is the one where we have a turning point at 2, and this is then -4. So this is -4, and that is 2. Okay, I also know that the y-intercept is easy to get because it's just x is equal to 0. So then the y-intercept was +16, was it? Where is it? Yeah, +16. So where my y-axis goes, just cuts there at +16. They also wanted me to show, draw the graph, show the intercepts, the coordinates of the turning points. Okay, so now I have to find the turning point. To find the turning points, I take the derivative and make it equal to 0. Okay, the derivative is 3x squared minus 12 is equal to 0, and so I get x squared minus 4 is equal to 0. So x plus 2, x minus 2 is equal to 0. So x is equal to -2, or x is equal to +2. And now I already know that is a turning point because of the roots of multiplicity. That means it has to be a turning point. Okay, so there is already my turning point, and then the other turning point is there. That must be at -2, and now to find that value, I would substitute f -2. I get -2 cubed minus 12 times -2 plus 16. So -2 cubed, so this together gives me 24 plus 16 is 40. 40 minus 8 is 32. So this value here is -2 for x and 32 for y. Okay, and that's it. And they also wanted the point of inflection, which is the second derivative equal to 0. So in other words, that gives me the 3 becomes 6x. 6x is equal to 0. So x is equal to 0. And then if x is equal to 0, then y is equal to 16. We already know that's the point of inflection then. So there we go. It's really very easy marks there. Okay. Very easy marks there to get all 6 points. Okay, a factory is manufacturing a rectangular container that has a length of the base is 3 times longer than the width. The cost of the material to manufacture the top and the base of the container is 100 Rand per square meters. The cost of the material to manufacture the side of the container is 50 Rand per square meter. The container must have a volume of that. Okay, let the width be equal to x meters. Okay, and then determine the expression for the height of the container in terms of x. So first of all, let me clear. Okay. So first of all, they say the width is equal to x. They say the breadth of it is the base 3 times longer. So the length it's 3 times longer than the width. So the length is equal to 3x. And then the height, we don't know what the height is, but we know the volume has to be, okay, volume has to be 9 square meters, so 9. So, and we know that volume is length times width times height, and so this is x times 3x, other way around actually, times height. That must be 9, so h is equal to 3 over x squared. I just divide both sides with 3 and 2 x's. Okay, and then the 3 divides into there to give me the 3. I'm not going to get into all of that. And I just did it. I didn't even go and look at what the student attempt was. Okay, that's because there was nothing to look at. We're looking at the wrong question. Question 9.2. Yeah, no, I'm looking at the right question. The student didn't do it. Okay, so let's go on. Show that the cost to manufacture the container can be expressed as. So here's the cost to manufacture the container, and they said the cost to manufacture the top and the base is 100 Rand, and the sides is 50 Rand per square meter. So if we look at the, we obviously need to draw a picture. I should have in the first place already drawn a picture, but there's my picture, and so I know the width and the length and the height. So the width being x, the length being 3x, and now I know that the height is 3 over x squared. Did the question give that to me? No, it didn't give that to me, so that makes this question quite hard. Okay, but the top and the bottom are made of the same material. So the top and the bottom, the area for that is the width times the length, and the width times the length cost 100 Rand per square meter. So this must be multiplied with 100, plus the sides are again a different material for the sides, and those sides are 50 Rand per square meters, but this time the area of this thing is now the height times the length. So it's the height times the length. So I get 100 times x times 3x is 100, so it's 300x squared, plus 50 times the height is now 3 over x squared times the length is 3x, and so that gives me a final answer of 300x squared plus, that's 450. Is that right? No. Do I have it the wrong way around? Okay, the top and the base is 100 Rand. The cost of the material. Okay, wait. I made a mistake. First of all, sorry, this must be doubled. Okay, the reason why that has to be doubled is because there's a top and a bottom. Sorry, I forgot to do that. So this is 600x squared, and then this one, okay, there's 2 of these. Shucks, that's quite embarrassing. I completely missed this. There's 2 of these guys, so they must also be doubled, and there's 2 of these guys. Okay, this side is the height and the width, so that's also 50 Rand, but this time it's the plus, so 2 times that plus 2 times 50 Rand for that times the height times the width, and the height is now still 3 over x squared, but the width is just x. So this one doubled. This one gives me 3 times 3 is 9 times 5 is times 50 is 450 over x, and it's over x because that x and that square cancels, so there's only an x left. And then on this one is plus, and again I must multiply this by 2, and I didn't multiply this by 2, sorry, so it's 900. And so this one multiplied also by 2 gives me 100 times 3, and also that one cancels, so this one is 300 over x, and then I can just add up. So I've got 600 x squared, maybe you can't see, plus, and then these two can be added because I've got the same denominators, 9 plus that. There we go. Okay, so it was a bit of a bumpy ride, but I got it in the end. Okay, so sorry, I've got lots of stuff open on my desktop. Determine the width of the container if the cost is a minimum. Okay, so we want to minimize the cost, which let me just get back there. Minimize the cost. This is the expression. So even if you couldn't do it, okay, still, even if you couldn't do it, you can still, or you couldn't show this, you can still do it from here, because I take the derivative and make it equal to 0. So the derivative being 1200, this one is x to the power of -1, so this is minus 1200 over x squared. If I take the derivative, it's x to the power of -1, take the derivative, that becomes -2, that's where I get that from, make it equal to 0, and then when I solve this, eventually I get 1200 over x squared is equal to 1200. Can you understand? Can you just see that x squared must therefore equal 1, because 1200 can only equal 1200 if it's divided by 1. And so x is equal to plus or minus 1, and you should write the plus or minus 1, but -1 doesn't make sense. It cannot be equal to -1, therefore x is equal to 1. That is the width to find a minimum cost. Okay, so that is the calculus question. Not too bad.